Hello everyone. Many of you have been asking for quite some time on a series on Microsoft Certified Azure Developer Associate exam. And here we are starting with first part of our AZ-204 Ultimate course. You develop an ASP.NET Core application by integrating the application insights SDK into your solution. The application sends a very high rate of telemetry in a short time interval. You observe a reduced number of events, traces, and metrics being recorded and increased error rates for telemetry ingestion. You need to reduce telemetry traffic, data costs, and storage costs while preserving a statistically correct analysis of application telemetry data. Your solution must ensure that you will be able to correlate HTTP request and response data. What should you do? Your options are configure a log analytics workspace data collection rule, use a custom query language statement to filter incoming data, disable adaptive sampling, enable and configure the fixed rate sampling module, set a daily cap on the log analytics workspace, create an activity log alert rule, configure the telemetry configuration object in the instrumented code, increase the metric aggregation interval to 15 minutes. Now folks, application insights uses adaptive sampling by default, which dynamically adjusts the sampling rate. Now adaptive sampling may break correlation if related telemetry items like dependencies, traces, or exceptions are dropped, which is why you need to use fixed rate sampling in this case. Now, fixed rate sampling lets you preserve all telemetry for a sampled request, enabling correlation of requests and its dependencies. It reduces traffic and cost by only retaining a representative sample of events. Next question. You have an Azure subscription that contains an application insights resource named AI-1 and an Azure App Service web app named App1. You create a standard availability test in AI-1. You set its URL to point to App1. You need to ensure that any failed tests generate email notifications to the owners of the subscription. What should you do? Your options are create an action group, create an alert rule, enable the test, enable the alert. And folks, you will need to create an alert rule here based on the availability test results. The alert rule must be linked to an action group which handles notifications like emails, SMS, webhooks. Enabling the alert is incorrect as you cannot enable it without creating it first. Next question. You have an Azure Application Insights resource named AI-1. AI-1 monitors an Azure App Service web app named App1. You plan to regularly analyze the usage of specific pages of App1 by a subset of users. The subset will consist of users who access specific App1 pages 5 or more times in a given month. You must be able to filter sessions and events based on that subset when viewing AI-1 in the Azure portal. You need to configure AI-1 to facilitate your analysis. What should you configure for AI-1? And the first part of the question is talking about feature to configure, and your options are cohort, funnel, user flow. Now friends, a cohort is a set of users, sessions, events, or operations that have something in common. In application insights, cohorts are defined by an analytics query enabling you for targeted analysis. Funnels shows step-by-step user progress, and user flow visualizes navigation paths. Now the next part of the question is talking about language to use, and your options are KQL, JSON, and XPath. You will define the cohort using the KQL query. JSON or XPath is not used in application insights for filtering or query logic. Next question. You create an Azure subscription. You then create an Azure resource group. You plan to create a containerized task that will run as an Azure container app in regular intervals. You need to automate the process of creating the task in the resource group by using Azure CLI commands. Which 3 actions should you perform in sequence? Your options are AZ container app job start, AZ container app env create, az container app job create, az container app connected dash dev create, az container app registry set, az provider register. Now, first of all, you will have to register required Azure resource providers. This must be done before using container apps for the first time in a subscription. This must be followed by creating a container apps environment which is required to host container apps or container jobs. You will finally create the containerized job specifying the container image, CPU memory, and schedule. Now friends, AZ container app job start is used to manually run an existing job. AZ container app registry set is used only if you are using a private container registry, and AZ container app connected dash dev create is for developer local debugging. So friends, I hope you now understand why the three actions that I have chosen are the correct answer. But if you still have any doubts, please post them in the comment section. Let's look at fifth question of the series. You have an on-premise internal only website named www.contoso.com and an Azure application insights instance named App Insights 1. You need to implement availability testing of www.contoso.com by using App Insights 1. Your solution must minimize development effort. How should you configure the test? The first part of the question is talking about www.contoso.com connectivity method. And your options are Azure private link, Azure service endpoint, Azure site-to-site VPN. Now folks, you will need to make use of Azure site-to-site VPN here, as you need private connection from Azure resources, which is a container or VM running the availability test, and on-premise systems. Now Azure private link enables you to access Azure PaaS services, which are Azure storage or Azure SQL database and Azure hosted customer owned partner services over a private endpoint in your virtual network. And service endpoints enable securing of Azure service resources to your virtual network by extending virtual network identity to the service. Once you enable service endpoints in your virtual network, you can add a virtual network rule to secure the Azure service resources to your virtual network. Both of these solutions are limited to connectivity within Azure. Now, the next part of the question is talking about availability test type. Your options are URL ping test, standard test, custom track availability test. Now, custom track availability test allows you to run a custom availability test from inside your network where the website is reachable. URL ping test and standard test requires the web page must be visible from the public internet and cannot reach internal only sites, which is why we can't use them here. Next question. You have a workspace based Azure application insights resource named Insights 1 and an Azure app service web app named App 1. Insights 1 collects telemetry generated by App 1. You plan to evaluate the alerting functionality of the availability testing that is enabled for App 1 by taking it offline for 50 minutes. You create a standard availability test for App 1, set its frequency to 15 minutes, and set its alert status to enabled. You need to assess the number of alerts that you would expect by taking App 1 offline for 50 minutes. How many alerts should you expect? Your options are 1, 2, 3, and 4. When App 1 goes offline, the first test fails and the system detects the availability drop and triggers one alert. That means one incident is now raised. The availability test continues to run every 15 minutes and those failures are logged in telemetry, but only one alert is raised for the ongoing incident unless you resolve and re-trigger the condition. Friends, always remember, alerts don't trigger again for the same incident unless the issue is resolved and it reoccurs after recovery, which is not the case here. Folks, if you're liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 7 of the series. You are implementing an application by using Azure Event Grid to push near real-time information to customers. You have the following requirements. You must send events to thousands of customers that include hundreds of various event types. The events must be filtered by event type before processing. Authentication and authorization must be handled by using Microsoft Entra ID. The events must be published to a single endpoint. You need to implement Azure Event Grid. The solution you choose is enable ingress, create a TCP scale rule, and apply the rule to the container app. Does this solution meet the goal? You need to tell whether this is right or wrong. And friends, this is an incorrect solution. We are trying to implement event-based pub sub, not container scaling or TCP networking logic. We should probably create an event grid topic or domain, define event subscriptions with event type filters, use webhook or Azure function endpoints, and secure them with Microsoft Entra ID based authentication. Next question. You are developing several Azure API management hosted APIs. You must make several minor and non-breaking changes to one of the APIs. The API changes include the following requirements: must not disrupt callers of the API, enable rollback if you find issues, documented to enable developers to understand what is new, tested before publishing. You need to update the API. What should you do? Your options are configure and apply header-based versioning, create and publish a product, configure and apply a custom policy, add a new revision to the API, configure and apply query string-based versioning. Now folks, headers-based versioning is used for breaking changes and managing multiple versions and is not needed for minor non-breaking changes. So let's rule it out. Now option B involves creating and publishing a product and product bundles APIs for exposure, which will not help with rollback or testing. So another incorrect choice. Now configuring and applying a custom policy will control the behavior of API like rate limits, making it another incorrect choice. An API revision allows you to safely introduce changes and keep the original version active for consumers, test and validate the revision privately, and roll back to a previous revision if needed, which is what we need here. It even allows you to add descriptions or documentations for the revision. Now, last option, which we know is incorrect, is for versioning similar to header based in option A. Ninth question. You are developing a solution by using the Azure Events Hubs SDK. You create a standard Azure Event Hub with 16 partitions. You implement 8 event processor clients. You must balance the load dynamically when an event processor client fails. When an event processor client fails, another event processor must continue processing from the exact point at which the failure occurred. All events must be aggregate and upload to an Azure Blob storage account. You need to implement event processing recovery for the solution. Which SDK feature should you use? The first part of the question is talking about ensure that event process clients mark the position within an event sequence. Your options are offset, checkpoint, namespace, or capture. Now folks, a checkpoint is a record that indicates the last successfully processed event in a partition. It's persisted in Azure Blob Storage by Event Processor SDK. This ensures that when a client fails, another client can resume from the last checkpointed position and not from the beginning. Now the next part of the question is talking about mark the event processor client position within a partition event sequence. And again, you have all the 4 similar options. Now offset is a value that uniquely identifies a position within an event hub partition's event stream. It's used internally by the SDK to know where to resume processing. Checkpointing stores this offset value as the recovery points. Now friends, in both of the options, I had a link on your screen. Go through the link to understand more about checkpoints and offsets. Let's look at next question. You are developing an Azure durable function to manage an online order processing. The process must call an external API to gather product discount information. You need to implement the Azure durable function. Which Azure durable function type should you use? You need to choose 2 options here. And your options are orchestrator, entity, client, and activity. Now friends, orchestrator function can be used to coordinate the workflow of the ordering process. It can call multiple activity functions in sequence, parallel, or conditionally. Next one would be activity function, which can perform specific tasks such as calling external API to fetch the discount information and perform data operations. As always, friends, go through the link on your screen to understand the different type of durable functions and their features in more detail. Let's look at 11th question of the series. You develop and deploy an ASP.NET Core application that connects to an Azure database for MySQL instance. Connections to the database appear to drop intermittently and the application code does not handle the connection failure. You need to handle the transient connection errors in code by implementing retries. What are three possible ways to achieve this goal? Your options are close the database connection and immediately report an error, disable connection pooling and configure a second Azure database for MySQL instance, wait 5 seconds before repeating the connection attempt to the database, set a maximum number of connection attempts to 10 and report an error on subsequent connections, increase connection repeat attempts exponentially up to 120 seconds. Now friends, the three possible ways to achieve the goal are now on your screen. Introducing a delay between retries helps avoid hammering the database during a transient issue, and 5 seconds is a common initial delay. Retry should not go on forever. Setting a retry cap avoids the infinite loops and resource execution. And you should implement exponential backoff where you start with small delays and increase them over time. This is a best practice for transient fault handling in cloud apps. Next question. You are developing an Azure-based web application. The application goes offline periodically to perform offline data processing. While the application is offline, numerous Azure Monitor alerts fire, which result in the on-call developer being paged. The application must always log when the application is offline for any reason. You need to ensure that the on-call developer is not paged during offline processing. What should you do? Your options are add Azure Monitor alert processing rules to suppress notifications, disable Azure Monitor service health alerts during offline processing, create an Azure Monitor metric alert, build an Azure Monitor action group that suppresses the alerts. Now friends, alert processing rules are the right solution in this use case. APRs allow you to suppress or modify alert notifications without disabling the alert rules themselves. Target specific time ranges, conditions, resources, and even action groups. They are dynamic and reversible, ideal for temporary offline windows. Next question. An organization hosts web apps in Azure. The organization uses Azure Monitor. You discover that configuration changes were made to some of the web apps. You need to identify the configuration changes. Which Azure Monitor log should you review? Your options are App Service App Logs, App Service Environment Platform Logs, App Service Console Logs, App Service Audit Logs. Now friends, platform logs include configuration change tracking such as app restarts due to setting changes, changes in pricing tier or scaling, and other environment level modifications. Refer to the link on your screen to read more about the remaining three log categories along with the other ones which are not mentioned in this question. You are developing an e-commerce solution that uses a microservice architecture. You need to design a communication backplane for communicating transactional messages between various parts of the solution. Messages must be communicated in first in, first out order. What should you use? Your options are Azure Storage Queue, Azure Event Hub, Azure Service Bus, Azure Event Grid. Now friends, Azure Service Bus is designed for enterprise-grade message broking between applications and services. It supports FIFO messaging via sessions or message ordering with queues or topics and provides transactional support, message deduplication, dead lettering, and advanced retry policies, making it the right choice. Next question. You are developing an ASP.NET Core website that can be used to manage photographs which are stored in Azure Blob storage containers. Users of the website authenticate by using their Microsoft Entra ID credentials. You implement role-based access control role permissions on the container that store photographs. You assign users to RBAC roles. You need to configure the website's Entra ID application so that users' permission can be used with the Azure Blob containers. How should you configure the application? Now, there are different settings that have been provided you in the list of options, which are client ID, profile, delegated, application, and user impersonation. Now friends, there are two APIs in question, which are Azure Storage and Microsoft Graph. You need to tell which permission and what type should you use to configure these APIs. Now friends, users need to access Azure Blob storage containers with their own permissions as mentioned in the question statement. Therefore, the permission will be user impersonation as it allows the application to act on behalf of the user. And since RBAC roles are assigned to the user, the app must use delegated permission. Now the second part of the question is talking about Microsoft Graph API, and here also delegated permissions are required because the app is acting on behalf of a signed in user. Now friends, client ID is simply the unique identifier of an app registration in Microsoft Entra ID. Application represents the app itself. And profile scope is an open ID connect scope that allows an application to access basic information about the signed in user. Question number 16. You develop a gateway solution for a public facing news API. The news API backend is implemented as a RESTful service and uses an OpenAI specification. You need to ensure that you can access the news API by using an Azure API management service instance. Which Azure PowerShell command should you run? Now on your screen, there are 4 commands mentioned. And friends, you will need to make use of import AZ API management API to import an API from a file or URL. New AZ API management backend defines a backend service. New AZ API management is used to create a new APIM interface. And new AZ API management backend proxy creates a new backend proxy object. Next question. You are developing applications for a company. You plan to host the applications on Azure App Services. The company has the following requirements. Every 5 minutes, verify that the websites are responsive. Verify that the websites respond within a specified time threshold. Dependent requests such as images and JavaScript files must load properly. Generate alerts if a website is experiencing issues. If a website fails to load, the system must attempt to reload the site 3 more times. You need to implement this process with the least amount of effort. What should you do? Your options are create a Selenium web test and configure it to run from your workstation as a scheduled task. Set up a URL ping test to query the homepage. Create an Azure function to query the homepage. Create a multi-step web test to query the homepage. Create a custom track availability test to query the homepage. Now friends, URL ping test and multi-step web test are deprecated already, so you can rule them out. Azure function requires custom development and retry logic, which means more effort, and we need to minimize the effort, so let's rule it out as well. Now Selenium test from workstation again requires manual setup and scheduling, so we will rule it out as well, leaving us with the correct option, which is option E, create a custom track availability test to query the home page. Now friends, you will need to use track availability in a custom availability test when the built-in test types do not meet advanced needs, which is what is happening here. Next question. You are developing an Azure service application that processes queue data when it receives a message from a mobile application. Messages may not be sent to the service consistently. You have the following requirements. Queue size must not grow larger than 80 gigabytes. use first in, first out ordering of messages, minimize Azure costs. You need to implement the messaging solution. And the solution you choose is use the .NET API to add a message to an Azure storage queue from the mobile application. Create an Azure VM that is triggered from the Azure storage queue events. Does this solution meet the goal? You need to tell whether this is right or wrong. And friends, this is an incorrect solution. You will need to use Azure Service Bus queue with sessions in this case. This ensures guaranteed FIFO ordering, message sessions to group ordered messages, and built-in retries and dead lettering. Next question. You're developing a solution that uses several Azure Service Bus queues. You create an Azure Event Grid subscription for the Azure Service Bus namespace. You use Azure Functions as subscribers to process the messages. You need to emit events to Azure Event Grid from the queues. You must use the principle of least privilege and minimize costs. Which Azure Service Bus values should you use? And the first part of the question is talking about the tier. Your options are basic, standard, and premium. And friends, you will need to use premium tier of Azure Service Bus here, as that's the only tier which supports Event Grid integration. Premium tier also provides VNet integration, dedicated resources, and low latency required for emitting events to Event Grid. Now the next part of the question is talking about access control level. And your options are contributor, data receiver, data sender, and data owner. You will have to provide contributor access in this case. Data receiver is for receiving data or messages. Data owner role grants full access to data operations, and data sender allows to send events to Event Grid, which should do the job. However, here Service Bus itself is the publisher and Event Grid requires contributor on the Event Grid topic, so Service Bus can publish to it. Folks, if you are liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 20 of the series. You develop a REST API. You implement a user delegation SaaS token to communicate with Azure Blob Storage. The token is compromised. You need to revoke the token. What are two possible ways to achieve this goal? Your options are revoke the delegation key, delete the stored access policy, regenerate the account key, remove the role assignment of the security principal. Now friends, user delegation SaaS depends on a user delegation key which is valid for a limited time and is issued by Entra ID. You can revoke this delegation key which effectively invalidates the existing user delegation SaaS tokens. You can also revoke the token by removing the role assignments of the security principal. Folks, always remember both the user delegation key and RBAC role assignments are cached by Azure Storage, so there may be a delay between when you initiate the process of revocation and when an existing user delegation SaaS becomes invalid. There is a link on your screen. Go through the link to understand more about how you can revoke the user delegation SaaS. Question number 21. You are developing an application that applies a set of governance policies for internal and external services as well as for the applications. You develop a stateful ASP.NET Core 2.1 web application named Policy App and deploy it to an Azure App Service web app. The Policy App reacts to events from Azure Event Grid and performs policy actions based on those events. You have the following requirements. Authentication events must be used to monitor users when they sign in and sign out. All authentication events must be processed by Policy App. Sign-outs must be processed as fast as possible. What should you do? Your options are create a new Azure Event Grid subscription for all authentication events. Use the subscription to process sign-out events. Create a separate Azure Event Grid handler for sign-in and sign-out events. Create separate Azure Event Grid topics and subscriptions for sign-in and sign-out events. Add a subject prefix to sign-out events. Create an Azure Event Grid subscription. Configure the subscription to use the subject begins with filter. Now friends, by Adding a subject prefix to sign out events, you can filter them at the event grid subscription level using subject begins with. This means only sign out events are routed to a dedicated handler or endpoint, allowing your app to process them faster and separately from other events. This approach is scalable, efficient, and optimized for performance without duplicating unnecessary infrastructure. Next question. You're developing an online game that includes a feature that allows players to interact with other players on the same team within a certain distance. The calculation to determine the players in range occurs when players move and are cached in an Azure cache for Redis instance. The system should prioritize players based on how recently they have moved and should not prioritize players who have logged out of the game. You need to select an eviction policy. Which eviction policy should you use? Your options are all keys LRU, volatile LRU, all keys LFU, volatile TTL. Volatile LRU would be the best suited eviction policy in this case. Volatile only evicts keys that have a TTL set, which will work perfectly if we expire logged out players, and LRU evicts the least recently used items, for example, players who haven't moved recently. This ensures active players stay cached and logout or inactive players are eligible for eviction. Question number 23. You develop and deploy an Azure App Service API app to a Windows hosted deployment slot named development. You create additional deployment slots named testing and production. You enable auto swap on the production deployment slot. You need to ensure that scripts run and resources are available before a swap operation occurs. The solution you choose is disable auto swap, update the app with a method named status check to run the scripts, re-enable auto swap, and deploy the app to the production slot. Does this meet the goal? You need to tell whether this is right or wrong. Folks, this approach doesn't leverage the built-in warm-up mechanism, so it doesn't fulfill the requirement to ensure readiness before the swap. You should leave auto swap enabled, implement a status check or warm-up logic, and set the website swap warm-up ping path app setting to status check. Next question. A company uses an Azure blob storage for archiving. The company requires that data in the blob storage is only in the archive tier. You need to ensure data copied to the blob storage is moved to the archive tier. What should you do? Your options are use a put block list operation with a request header of XMS immutability policy mode. Create a lifecycle policy with an action of tier 2 archive and configure days after modification greater than for 0. Use a put blob operation with a request header for XMS immutability policy until date. Create a lifecycle policy with an action of tier 2 archive and configure a filter for blob index match. Now friends, you want to ensure that any data copied to Azure blob storage is immediately moved to the archive tier. This can be best accomplished using a lifecycle management policy, so you can rule out option A and option C straight away. We know the action needs to be tier 2 archive as the goal is to move everything to archive tier. You will need to configure days after modification greater than to 0, as this applies the action immediately after the blob is uploaded or modified. Now, lifecycle policy with blob index match filter targets specific blobs based on tags or index, but doesn't guarantee all blobs go to archive, which is why we have ruled it out. Question number 25 of the series. You have an Azure queue storage named Q1. You plan to develop code that will process messages in Q1. You need to implement a queue operation to set the visibility timeout value of individual messages in Q1. Which two operations can you use? Your options are peek at a message in the queue, delete a message in the queue, add a message to the queue, update a message in the queue, receive a message from the queue. And friends, the two correct operations that you can use here are receive and update a message. When you receive a message, you can specify the initial visibility timeout. You also get the pop receipt, which is required to later update or delete the message. This makes the message temporarily invisible while you process it. Now, after receiving the message, you can update its visibility timeout using the update message operation. This is useful if your processing is taking longer and you want to extend the invisibility period. Next question. A company has an Azure Cosmos DB for NoSQL account. The account is configured for session consistency. Data is written to a single Azure region and data can be read from 3 Azure regions. An application that will access the Azure Cosmos DB for NoSQL container data using an SDK has the following requirements. Reads from the application must return the most recent committed version of an item from any Azure region. The container items should not automatically be deleted. You need to implement the changes to the Azure Cosmos DB for NoSQL account. What should you do? The first part of the question is talking about reads must return the most recent committed version of an item. Your options are change the consistency level by using the SDK, change the default consistency level on the account, configure the integrated cache on the account, configure the account to write data to multiple Azure regions. Now friends, the default consistency level of the account is session, which guarantees read your writes within the same sessions. To read the most recent committed version from any region, you must use strong consistency at request level, which can be done using the SDK, even if the account default is session, making option A as the correct choice. Now, changing the default consistency level on the account affects all requests globally, which might increase latency. Configuring the integrated cache can serve stale data and not suitable for returning the latest committed version. Configuring the account to write data to multiple Azure regions is not needed to read the latest committed data. Now friends, the next part of the question is talking about items should not automatically be deleted. And your options are change the TTL property on items to 0, change the TTL property on items to -1, configure a resource lock on the account, configure a resource lock on the container. Now, time to live is used in Cosmos DB to automatically delete items after a specified time, and to prevent auto deletion, you must set TTL to -1. Setting TTL to 0 seconds means items are deleted immediately after insert, and configuring a resource lock on account or container prevents accidental deletion of the entire resource, not data within the container. You have an Azure Cosmos DB for NoSQL API account named account1. Multiple instances of an on-premise application named app1 read data from account1. You plan to implement integrated cache for connections from the instances of app to account1. You need to set the connection mode and maximum consistency level of app1. Which values should you use for the configuration settings? The first part of the question is talking about connectivity mode. Friends, the options are direct mode, gateway mode using standard gateway, gateway mode using dedicated gateway. Now, folks, we want to use integrated cache, which only works with dedicated gateway. The SDK must be configured to use gateway mode to take advantage of the integrated cache, and the integrated cache has two parts, which is an item cache for point reads and a query cache for queries. Now, the next part of the question is talking about consistency level. Your options are strong, session, eventual. Now, integrated cache supports session, consistent, prefix, and eventual consistency. Since we want to balance consistency and performance for multiple instances of app1, session consistency is recommended. Folks, there is a link on your screen. Go through the link to understand more about how integrated cache consistency works and how you can configure it. Let's look at next question. You are developing an Azure hosted e-commerce web application. The application will use Azure Cosmos DB to store sales orders. You are using the latest SDK to manage the sales orders in the database. You create a new Azure Cosmos DB interface. You include a valid endpoint and valid authorization key to an app settings.json file in the code project. You are evaluating the following application code. Now there is the application code in front of you and the line numbers are included for reference only. Go through the application code and then based on that, you need to tell whether the statements being talked about in the question are correct or incorrect. Friends, the first statement is a database named sales orders is created. The database will include two containers. This is a correct statement. We are creating a database named sales orders at line 22, and then line 23 and 24 refer to creating containers named container 1 and container 2 in the database. Now the second statement is container 1 will contain two items. This is also a correct statement. Line 26 and 28 confirm two items named sales order 1 and sales order 2 being inserted in container 1. Now the third statement is container 2 will contain one item. And friends, the third and final statement is also correct. Line 30 confirms sales order 3 is the only item in container 2. Now friends, if you still have any doubts on why I have chosen a particular statement as correct, then make sure to post them in the comment section and I'll try to address them as soon as possible. Let's look at question number 29. You are implementing an application by using Azure Event Grid to push near real-time information to customers. You have the following requirements. You must send events to thousands of customers that include hundreds of various event types. The events must be filtered by event type before processing. Authentication and authorization must be handled by using Microsoft Entra ID. The events must be published to a single endpoint. You need to implement Azure Event Grid. The solution you choose is publish events to an event domain, create a custom topic for each customer. Does this solution meet the goal? You need to tell whether this is right or wrong. And friends, this is a correct solution. Event domains allow you to manage a large number of related event topics, typically in a multi-tenant application. And you can authenticate, publish requests to an event domain using Microsoft Entra ID. Next question. A company is developing a solution that allows smart refrigerators to send temperature information to a central location. The solution must receive and store messages until they can be processed. You create an Azure Service Bus instance by providing a name, pricing tier, subscription, resource group, and location. You need to complete the configuration. Which Azure CLI or PowerShell command should you run? Your options are in front of your screen. Basically, they are 4 different commands. Now, friends, you will need to use the command in option A to create a queue in an existing service bus namespace, which is what we need here. The queue will store incoming messages from the smart refrigerators. Now, option B uses a Azure RM command, which is already deprecated. Option C creates a namespace, which already exists as per question statement. And option D creates a resource group, which is irrelevant here. Question number 31. You have a standard tier instance of Azure Cache for Redis named Redis 1, configured with the default settings. You need to configure a max memory policy to increase the amount of cache available for read operations. How should you configure the max memory policy? Your options are decrease the value of max memory reserved, increase the value of max memory reserved, set the max memory policy to no eviction, set the max memory policy to volatile LRU. Now, folks, the question specifically talks about configuring the max memory policy and you should set it to volatile LRU. The max memory policy in Azure Cache for Redis controls how keys are evicted when the Redis cache reaches its memory limit. Volatile LRU evicts the least recently used keys that have an expiration set, meaning this policy preserves frequently accessed keys, improving cache effectiveness for read-heavy operations. Now, friends, decreasing max memory reserved will help marginally, but not as effective as setting the max memory policy to volatile LRU. Increasing max memory reserved is counterproductive as it will reduce the cache space, and no eviction will force Redis to start returning errors when memory is full. Question number 32. You have an Azure App Service web app named Web App 1 and an Azure Functions app named Functions 1. Web App 1 is associated with an application insights instance named App Insights 1. You configure a web test and a corresponding alert for Web App 1 in App Insights 1. Each alert triggers a delivery of email to your mailbox. You need to ensure that each alert also triggers execution of function 1. The solution you choose is configure an application insights smart detection. Does this meet the goal? You need to tell whether this is right or wrong. Folks, this is an incorrect solution. Smart detection in application insights automatically detects issues like performance degradations and failure anomalies. However, it does not provide a way to trigger an Azure function directly when an alert is raised. You should configure an action group in the alert rule that includes a webhook or Azure Functions action. Let's look at next question of the series. You manage an Azure subscription that contains 100 Azure App Service web apps. Each web app is associated with an individual application insights instance. You plan to remove classic availability tests from an application insights instance that have this functionality configured. You have the following PowerShell command. The command you are using is get az application insights web test, and then with a where object, a condition is defined. You need to set the value of the condition variable. Which value should you use? Now in front of you, there are basically 4 options. Now friends, web test kind is the correct property that identifies the type of availability test. Ping refers to classic availability tests which are being deprecated, and standard refers to the newer availability tests based on standard tests. Folks, there is a link on your screen. Go through it to understand more about the PowerShell command get az applications insight web test. Let's look at question number 34 of the series. You have an Azure API management standard tier instance named EP1 that uses a managed gateway. You plan to use EP1 to publish an API named API1 that uses a backend database that supports only a limited volume of requests per minute. You also need a policy for API1 that will minimize the possibility that the number of requests to the backend database from an individual IP address you specify exceeds the supported limit. You need to identify a policy for API1 that will meet the requirements. Which policy should you use? Your options are IP filter, quota by key, rate limit by key, and rate limit. Now folks, the goal here is to minimize the possibility that the number of requests to the backend database from an individual IP address exceed the supported limit. So you will use rate limit by key policy. This policy limits the call rate based on a key such as caller IP, subscription key, user ID, etc. Now rate limit limits calls globally, not per key, which is the key requirement here. IP filter allows or denies requests from specific IPs, and quota by key is for longer term quotas. Question number 35 of the series. You are developing several microservices to run on Azure Container Apps. You need to monitor and diagnose the microservices. Which features should you use? The first part of the question is talking about view console logs from a container in near real time. Your options are log streaming, container console, Azure monitor metrics, Azure monitor log analytics. And friends, you should use log streaming in this case. Log streaming allows you to view container standard output or standard error logs in near real time and is useful for debugging and tracking live activity in your container apps. Now friends, the next part of the question is talking about feature to use for debugging the microservice form inside the container. And the options are container console, Azure monitor metrics, Azure container registry, Azure monitor log analytics. You will have to use container console in this case. It gives you interactive shell access into a running container, letting you explore logs, run commands, and debug directly inside the container instance. Now, friends, Azure Monitor Metrics provides performance metrics. Azure Monitor Log Analytics is useful for querying logs after aggregation, and Azure Container Registry hosts container images. Next question. You are building an application to track cell towers that are available to phones in near real time. A phone will send information to the application by using the Azure Web PubSub service. The data will be processed by using an Azure Functions app. Traffic will be transmitted by using a content delivery network. The Azure function must be protected against misconfigured or unauthorized invocations. You need to ensure that the CDN allows for the Azure function protection, which HTTP header should be on the allowed list. Your options are authorization, webhook request callback, resource, webhook request origin. Friends, when protecting Azure functions acting as a HTTP webhooks, Microsoft recommends validating the origin of requests using the webhook request origin header. This header helps identify and allow only approved origins, and it is especially important when integrating with CDNs or external services, ensuring that only known sources can call your function. Folks, if you're liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 37 of the series. You have a web app named EP1 hosted on your on-premise web server. You plan to use the application insights JavaScript SDK to implement client-side real user monitoring of individual pages of EP1. You need to author the script element that will be added to each of the pages. What should you set for the value of source and config keys in the script element of each page? Now, friends, the first part of the question is talking about source. And your options are URL to download the SDK from, application insights connection string, app ID used to correlate AJAX dependencies on the client side with the server side requests. And friends, source would be the URL to download the SDK from. This is the official CDN URL from which the application insights SDK script is downloaded. Now, the next part of the question is talking about config. And you have the options as URL to download the SDK from, application insights connection string, and the third one, which is different, is cross-origin attribute designating support for cross-origin resource sharing. Config would be application insights connection string. This is required to route telemetry data to the correct application insights resource. Let's look at question number 38 of the series. You plan to implement an Azure Functions app. The Azure Functions app has the following requirements. Must be triggered by a message placed in an Azure storage queue. Must use the queue name set by an app setting named input queue. Must create an Azure blob storage named the same as the content of the message. You need to identify how to reference the queue and blob name in the function.json file of the Azure Functions app. How should you reference the names? The first part of the question is talking about queue name. And then you have three options, which are the variations of the input queue. Now, folks, in Azure Functions, app settings can be referenced in functions.json using app setting name inside the percentage marks. So if the app setting is named as input underscore queue, the queue name should be percentage input underscore queue percentage. Now, the second part of the question is talking about the blob name. And the three options are now on your screen. The message from the Azure storage queue trigger is automatically bound to a variable called queue trigger. You can use queue trigger within curly braces to dynamically name the blob based on the content of the queue message. All the remaining options are invalid syntax. Before we proceed, folks, I would like to introduce you to my TopMate profile. If you are seeking guidance on clearing certification exams, considering a career transition into DevOps or cloud computing, or require support with resume reviews or mock interviews, you can easily schedule a one-to-one session with me via TopMate. You will also find digital products available for purchase, including PDF version of all the certification questions featured on the channel. PDF will be available for download instantly as soon as purchase is completed. For any specific queries, feel free to use the priority DM option. I will respond as soon as possible. Do not forget to take advantage of the tips and coupon codes available at the top of my TopMate profile to enjoy these benefits at minimal cost. Friends, link to my TopMate profile is available in the description section of this video. You are developing an Azure solution to collect inventory data from thousands of stores located around the world. Each store location will send the inventory data hourly to an Azure Blob storage account for processing. The solution must meet the following requirements. Begin processing when data is saved to Azure Blob storage. Filter data based on store location information. Trigger an Azure Logic app to process the data for output to Azure Cosmos DB. Enable high availability and geographic distribution. Allow 24 hours for retries and implement an exponential backoff data processing. You need to configure the solution. What should you implement? Now you have the technologies mentioned as Azure Event Hub, Azure Event Grid, Azure Service Bus, Azure Blob Storage, Azure App Service, and Azure Logic App. Now the first part of the question is talking about what would be the event source. Now friends, data is uploaded hourly from each store, so blob storage events can be used to start the workflow as soon as files are added. Now the next part of the question is talking about event receiver. You should make use of Azure Event Grid here, as it is designed to react to blob storage events in near real time. It's highly available, globally distributed, and supports retry with exponential backoff for up to 24 hours. Event Grid can also filter events based on metadata, for example, store location, before forwarding them. Now the last part of the question is talking about event handler. And you can use logic apps to process the incoming data and insert it into Azure Cosmos DB. Now friends, Event Grid can directly trigger a logic app via webhook or built-in connector. Let's look at question number 40. You manage an Azure Cosmos DB for a NoSQL API account named account1. The account contains a database named DB1, which contains a container named container1. You configure account1 with a session consistency level. You plan to develop an application named app1 that will access container1. Individual instances of app1 must perform reads and writes. App1 must allow multiple nodes to participate in the same session. You need to configure an object to share the session token between the nodes. Which object should you use? Your options are document response, request options, feed options, connection policy. Request options object allows you to specify options for individual requests, including the session token. By setting the session token in the request options, you can ensure that multiple nodes in your application share the same session token, thereby maintaining session consistency across those nodes. Let's look at question number 41. You have a static website hosted in an Azure storage account named storage1. You access the website by using a URL that ends with the web.core.windows.net suffix. You plan to configure the website to be accessible through the URL www.contoso.com. The website must be accessible during the configuration. The contoso.com zone is hosted in Azure DNS. You need to complete the website configuration. Which 4 actions should you perform in sequence? And friends, we are talking about domain name configuration steps here. And your options are create a CNAME record as verify.www.contoso.com in Azure DNS, set the custom domain name of storage1 to www.contoso.com, identify the host name of the storage endpoint of the website, create an A record as verify.www.contoso.com in Azure DNS, create a CNAME record www.contoso.com in Azure DNS. Now friends, you should start with identifying the host name of the storage endpoint of the website. This will be followed by creating a CNAME record as verify.www.contoso.com in Azure DNS. The next step would be to set the custom domain name of storage to www.contoso.com, which will trigger Azure to check the as verify CNAME for validation. And friends, the final step would be to create a CNAME record www.contoso.com in Azure DNS. Folks, there is a link on your screen and I would highly recommend you to go through it to understand this setup in more detail. Next question. You manage an Azure storage account named storage1. You plan to load 1 million blobs into storage1. You must assign key value pairs to blobs so that both keys and their values are automatically indexed and searchable by using the built-in services of storage1. You need to run the command to assign key value pairs. Which command should you run? Your options are update AZ storage blob service property, set AZ storage blob tag, AZ storage blob service dash properties update, set AZ storage blob content. Now friends, Azure Storage supports blob indexing via blob tags. These are key value attributes stored with the blob metadata that are automatically indexed for server-side search using the find blobs by tags features. And in Azure PowerShell, the commandlet for assigning tags is set AZ storage blob tag. Now update AZ storage blob service property is used to update service-wide properties which are like codes, metrics, delete retention of a storage account. Now AZ storage blob service properties update is the Azure CLI equivalent of the previous PowerShell command. And set AZ storage blob content uploads a file to a blob but does not directly assign tags. Next question. You have an Azure blob storage account named account1. You plan to grant permissions for access to blobs in account1 by using a combination of a shared access signature token and a stored access policy. You must set the duration of the token validity by using the stored access policy. You need to complete the configuration of the stored access policy and generate the shared access signature token. Which token setting and token type should you use? The question is talking about storage access configuration. And the first part is token setting to configure. Your options are protocol, source IP, and permissions. Now friends, a stored access policy in Azure storage is defined at the container level and allows you to set start and expiry times of tokens, set permissions like read, write, delete, list, etc., and associate one or more SAS tokens to it. Now the next part of the question is talking about the token type to generate, and your options are account shared access signatures, blob container shared access signatures, user delegation shared access signatures. Now folks, when you create a SAS linked to a stored access policy, the permissions are taken from the policy, not the token directly. The duration, which is the validity, is also taken from the stored access policies start and expiry times. And to use a stored access policy for blobs, you must generate a blob container SAS. Now friends, account SAS operates at the storage account level, but stored access policies cannot be used with account SAS, and user delegation SAS is for Entra ID delegation but is not tied to stored access policies. Let's look at question number 44 of the series. You are developing a solution for a public facing API. The API backend is hosted in an Azure App Service instance. You have implemented a RESTful service for the API backend. You must configure backend authentication for the API management service instance. The solution you choose is you configure basic gateway credentials for the Azure resource. Does this solution meet the goal? You need to tell whether this is right or wrong. And friends, this is an incorrect solution. Basic gateway credentials in Azure API management are used for securing API management's access to backend services when those services require basic authentication. However, we are talking about a public facing API and you would typically use managed identity with Entra ID authentication or client certificate authentication or subscription key and OAuth 2.0 depending on the scenario. So friends, I hope you now understand why I have chosen this solution as an incorrect solution. But if you still have any doubts, please post them in the comment section. Let's look at question number 45. You have a Linux container-based console application that uploads image files from customer sites all over the world. A backend system that runs on Azure virtual machine processes the images by using the Azure Blobs API. You are not permitted to make changes to the application. Some customer sites only have phone-based internet connections. You need to configure the console application to access the images. What should you use? Your options are Azure Blobfuse, Azure Disks, Azure Storage Network File System 3.0 support, Azure Files. And friends, you should make use of Azure Blobfuse in this case. Now, Blobfuse is a virtual file system driver for Azure Blob Storage that lets you mount a Blob container as if it were a local file system inside your Linux container. Now, friends, Azure disks are attached to a VM. Azure Storage NFS 3.0 is used for large-scale analytics and HPC workloads. And Azure Files is a SMB or NFS-based file share, but the backend here uses Azure Blob Storage API. Next question. You are developing a static website hosted on Azure Blob Storage. You create a storage account and enable static website hosting. The website must support the following requirements: custom domain name, custom header values for all responses, custom SSL certificate. You need to implement the static website. What should you configure? The first part of the question is talking about custom domain name. And your options are Blob Index Tags, Azure Content Delivery Network, Cross-Origin Resource Sharing, Azure Storage Service Encryption. Now friends, a static website hosted directly on Azure Blob Storage supports static file serving and optional custom error and index pages. However, Blob Storage static websites by themselves do not natively support custom SSL certificate, setting custom HTTP headers for all responses, or mapping a custom domain name with HTTPS. The solution is to place Azure CDN in front of the Blob Storage endpoint. Now the CDN can map custom domain to the Blob endpoint. Next part of the question is talking about the custom header values, and you have the same 4 options. And friends, here also you will utilize CDN. CDN allows adding or modifying HTTP response headers globally. Now the final part of the question is talking about custom SSL certificate. And this can also be implemented using Content Delivery Network. CDN supports HTTPS with your own SSL cert or a free managed certificate. There is a link on your screen. Go through the link to understand more about how you can use Content Delivery Network to implement a custom SSL certificate in this case. Friends, if you are liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 47 of the series. You develop a web application that provides access to legal documents that are stored on Azure Blob Storage with version level immutability policies. Documents are protected with both time-based policies and legal hold policies. All time-based retention policies have the allow protected append rights property enabled. You have a requirement to prevent the user from attempting to perform operations that would fail only when a legal hold is in effect and when all other policies are expired. You need to meet the requirement. Which two operations should you prevent? Your options are adding data to documents, deleting documents, creating documents, overwriting existing documents. Now friends, a legal hold stores immutable data until the legal hold is explicitly cleared. When a legal hold is set, objects can be created and read, but not modified or deleted, making option B and option D as the correct choice here. Now friends, go through the link on your screen to read more about time-based retention policies and legal hold policies, which is the crust of this question. Next question. You are updating an application that stores data on Azure and uses Azure Cosmos DB for storage. The application stores data in multiple documents associated with a single username. The application requires the ability to update multiple documents for a username in a single ACID operation. You need to configure Azure Cosmos DB. Which two actions should you perform? Your options are create a collection sharded on username to store documents, configure Azure Cosmos DB to use the Gremlin API, create an unsharded collection to store documents, configure Azure Cosmos DB to use the MongoDB API. Now folks, to update multiple documents for a username in a single ACID operation in Azure Cosmos DB, you need to ensure that the documents are stored in the same logical partition. To do this, you should create an unsharded collection to store documents. This will ensure that all documents are stored in the same logical partition, and you should then configure Azure Cosmos DB to use the MongoDB API. The MongoDB API supports multi-document ACID transactions, which allow you to update multiple documents in a single atomic operation. Question number 49 of the series. You are developing an Azure service application that processes queue data when it receives a message from a mobile application. Messages may not be sent to the service consistently. You have the following requirements. Queue size must not grow larger than 80 gigabytes. Use first in first out ordering of messages. Minimize Azure costs. You need to implement the messaging solution. And the solution you choose is use the .NET API to add a message to an Azure storage queue from the mobile application. Create an Azure function that uses an Azure storage queue trigger. Does this meet the goal? You need to tell whether this is right or wrong. And friends, this is again an incorrect solution. You will need to use Azure Service Bus Queue with sessions in this case. This ensures guaranteed FIFO ordering, message sessions to group ordered messages, and built-in retries and dead lettering. Let's look at question number 50 of the series. You implement an Azure solution to include Azure Cosmos DB, the latest Azure Cosmos DB SDK, and the core SQL API. You also implement a change feed processor on a new container instance by using the Azure Functions trigger for Azure Cosmos DB. A large batch of document continues to fail when reading one of the documents in the batch. The same batch of documents is continuously retired by the triggered function, and a new batch of documents must be read. You need to implement the change feed processor to read the documents. Which feature should you implement? Now the first part of the question is talking about read a new batch of documents while keeping track of the failing batch of documents. Your options are lease container, dead letter queue, lifecycle modifications, change feed estimator. Friends, you want to keep track of failed documents so they don't block the rest of the processing and they are stored separately in dead letter queue. Lease container is what the change feed processor uses to maintain a state. It tracks the last read position for each partition. And change feed estimator is a feature or API that measures how many items are left to process in the change feed. Now the next part of the question is talking about what feature should you use to handle errors in the change feed processor. Again, you have the same four options. Now, when you want to manage processing errors like retries, cleanup, special processing, you will still use a dead letter queue pattern. This way you send failed documents to a dead letter container or queue for later inspection instead of retrying infinitely. Now friends, lifecycle modifications refer to handling time to live and item deletion in Cosmos DB to manage document lifecycle automatically. You are developing an application to store millions of images in Azure Blob Storage. The images are uploaded to an Azure Blob Storage container named Company Images contained in an Azure Blob Storage account named Company Media. The stored images are uploaded with multiple blob index tags across multiple blobs in the container. You must find all blobs whose tags match a search expression in the container. The search expression must evaluate an index tag named status with a value of final. You need to construct the get method request URI. How should you complete the URI? The parameters given in the options are status equals final, status less than equals final, company media, company images. Now friends, the get method request URI is in front of you and there are 3 blanks that you need to fill. And the correct complete command is now on your screen. Storage account name is company media, which is what needs to be added at the start of the URI. This will be followed by the reference to container name, that is company images. And lastly, the condition would be status equals to final. Let's look at question number 52 of the series. You create and publish a new Azure App Service web app. User authentication and authorization must use Microsoft Entra ID. You need to configure authentication and authorization. What should you do first? Your options are add an identity provider, map an existing custom DNS name, create and configure a new app setting, add a private certificate, create and configure a managed identity. And friends, you should add an identity provider. Mapping an existing custom domain name is only needed if you want your web app to use a custom domain. App settings may be needed later for secrets or environment variables. Certificates are only required for SSL or TLS and for certain secure communication scenarios. And managed identities are for resource-to-resource authentication within Azure, not for authenticating users of your app. Next question. You create an Azure Cosmos DB for NoSQL database. You plan to use the Azure Cosmos DB .NET SDK version 3 API for NoSQL to upload the following files. There are basically 5 files in the question named as file 1 through file 5 and the sizes are 1 MB through 5 MB. You receive the following error message when uploading the files. 413 entity too large. You need to determine which files you can upload to the Azure Cosmos DB for NoSQL database. Which files can you upload? Your options are different combinations of all the 5 files being mentioned in the table in the question. Now friends, maximum size limit of an item in Azure Cosmos DB is 2 MB. So you should be able to upload file 1 and file 2, making option B as the correct choice. Now folks, let's go through Microsoft documentation and understand some more limits that are applicable to an item in Azure Cosmos DB. So friends, let's go through this table which applies to per item limits. Now the maximum size of an item can be 2 MB, which is what our question was based on. The maximum length of partition key value can be 2048 bytes. Maximum length of ID value can be 1023 bytes. Allowed character for ID value. Server side, all Unicode characters except for backward and forward slash are allowed. Now there is a warning. I would highly recommend you to go through that warning as well. Now there are some resources mentioned for which there is no practical limit. And then the maximum level of nesting for embedded objects or arrays set to 128. Make sure you have that into consideration while you get such type of questions. Then there is a maximum TTL value defined and some more maximum or minimum applicable values are defined. Now, the key thing to note here is large document sizes of up to 16 MB are supported with Azure Cosmos DB for MongoDB only. So friends, in our question, we were talking about NoSQL API. That's the reason why we were saying that the maximum size of an item is 2 MB, but if the question is talking about MongoDB, then that value changes to 16 MB. Make sure to keep that in mind. Question number 54 of the series. You are developing an application to store business critical data in Azure Blob storage. The application must meet the following requirements. Data must not be modified or deleted for a user specified interval. Data must be protected from overwrites and deletes. Data must be written once and allowed to be read many times. You need to protect the data in the Azure Blob storage account. Which two actions should you perform? Your options are configure a time-based retention policy for the storage account, create an account shared access signature, enable the blob change feed for the storage account, enable version level immutability support for the storage account, enable point in time restore for containers in the storage account, create a service shared access signature. Now folks, the first action would be to configure a time-based retention policy. With a time-based retention policy, users can set policies to store data for a specified interval. When a time-based retention policy is set, objects can be created and read, but not modified or deleted. After the retention period has expired, objects can be deleted, but not overwritten. Now you should also enable version level immutability support for the storage account. This lets you apply immutability at the blob version scope in addition to container scope to protect against overwrites and deletes. Next question. You are developing a solution to store documents in Azure Blob Storage. Customers upload documents to multiple containers. Documents consist of PDF, CSV, Microsoft Office format, and plain text files. The solution must process millions of documents across hundreds of containers. The solution must meet the following requirements. Documents must be categorized by a customer identifier as they are uploaded to the storage account. Allow filtering by the customer identifier. Allow searching for information contained within a document. Minimize costs. You create and configure a standard general purpose V2 storage account to support the solution. You need to implement the solution. What should you implement? Friends, the first part of the question is talking about search and filter by customer identifier. Your options are Azure Cognitive Search, Azure Blob Index Tags, Azure Blob Inventory Policy, Azure Blob Metadata. Folks, we want to tag each document with a customer identifier and then be able to filter or search on that. So you should make use of blob index tags. They store key value pairs that are automatically indexed by Azure Storage, enabling fast filtering and searching across containers. Now, blob metadata allows you to store key value pairs, but metadata is not indexed for efficient search. Filtering millions of documents would be slow and not a scalable solution. Friends, the next part of the question is talking about search information inside documents. And again, you have all those four options. Now, goal here is to extract and search the content of PDF, CSV, Office files, text files, and you should use Azure Cognitive Search for that, as it provides full text indexing, OCR, and natural language search on document content. It integrates with blob storage via indexers. Remaining options only work on metadata or system properties and not document content. Question number 56 of the series. You are developing an Azure solution to collect point of sale device data from 2000 stores located throughout the world. A single device can produce 2 megabytes of data every 24 hours. Each store location has 1 to 5 devices that send data. You must store the device data in Azure Blob Storage. Device data must be correlated based on a device identifier. Additional stores are expected to open in the future. You need to implement a solution to receive the device data. The solution you choose is provision an Azure event grid, configure the machine identifier as the partition key and enable capture. Does the solution meet the goal? You need to tell whether this is right or wrong. And friends, this is the incorrect solution. The correct approach here would typically be Azure Event Hubs with capture, partition by device ID, and store in blob storage. Friends, if you're liking the content, do not forget to hit the like button and subscribe the channel. Let's move on to question number 57 of the series. You have an existing Azure storage account that stores large volumes of data across multiple containers. You need to copy all data from the existing storage account to a new storage account. The copy process must meet the following requirements: automate data movement, minimize user input required to perform the operation, ensure that the data movement process is recoverable. What should you use? Your options are AZ Copy, Azure Storage Explorer, Azure Portal, .NET Storage Client Library. Folks, the obvious correct answer here is AZ Copy. It is a command line tool built for fast automated data transfer between storage accounts and supports resumable uploads and copies and retry logic. It requires minimal user input once the command is configured. Next question. An organization deploys Azure Cosmos DB. You need to ensure that the index is updated as items are created, updated, or deleted. What should you do? Your options are set the indexing mode to lazy, set the value of the automatic property of the indexing policy to false, set the value of the enable scan inquiry option to true, set the indexing mode to consistent. Now friends, setting the indexing mode to lazy updates the index asynchronously, not immediately. Index is eventually consistent but not updated right away. Now setting the automatic property to false disables automatic indexing means you would have to manually specify index updates. Setting the enable scan in query value to true allows queries to scan data without indexes but does not update the index. Setting index mode to consistent ensures the index is updated synchronously with create, update, delete operations. This guarantees queries always see up-to-date index data. Now friends, there is a link on your screen. Go through the link to understand more about different type of indexing policies in Azure Cosmos DB. Question number 59 of the series. You are developing a solution that uses the Azure Storage Client Library for .NET. You have the following code. Now line numbers are included for reference only. Folks, take some time, go through this snippet and then look at the next part of the question, where we are talking about different statements and you need to tell whether those statements are right or wrong. Folks, the first statement is the code creates an infinite lease. This is a correct statement. Now line 5, acquire lease as sync null requests an infinite lease because the lease duration is null. Now this second statement is the code at line 6 always creates a new blob. This is an incorrect statement. Get blob reference where src.name is specified just creates a reference to the blob in the same container. Now the third statement is the finally block releases the lease. This is a correct statement. In the finally block, if lease state is not equals to available, it calls break lease sync, which breaks the lease. Next question. You develop an Azure app service web app and deploy to a production environment. You enable application insights for the web app. The web app is throwing multiple exceptions in the environment. You need to examine the state of the source code and variables when the exceptions are thrown. Which application insights feature should you configure? Your options are smart detection, profiler, snapshot debugger, standard test. Now folks, Snapshot debugger captures snapshots of the application's state at the time exceptions are thrown. This includes variables, call stack, and source code line. Smart detection automatically detects anomalies and failures. Profiler captures performance traces, and a standard test is used for availability testing. Next question, friends. You are developing a web application that uses Azure Cache for Redis. You anticipate that the cache will frequently fill and that you will need to evict keys. You must configure Azure Cache for Redis based on the following predicted usage pattern. A small subset of elements will be accessed much more often than the rest. You need to configure the Azure Cache for Redis to optimize performance for the predicted usage pattern. Which two eviction policies will achieve the goal? Your options are no eviction, all keys LRU, volatile LRU, all keys random, volatile TTL, volatile random. Now folks, all keys LRU evicts the least recently used item across all keys, making it perfect for hot or cold usage patterns. Volatile LRU evicts least recently used items only among keys with a TTL set, making it good if TTLs are used. Now folks, let's understand all the eviction policies in more detail. So friends, on your screen is an article on Redis website which is talking about the different eviction policies. So the first one is no eviction. Keys are not evicted, but the server will return an error when you try to execute commands that cache new data. If your database uses replication, then this condition only applies to the primary database. Note that commands that only read existing data will still work as normal. So friends, the first policy is no eviction, which obviously is not going to evict any keys and you are going to start seeing errors. All keys LRU is the one which we already discussed in the question, which evicts the least recently used keys. Now all keys LFU evicts the least frequently used keys. All keys random evict keys at random. Friends, the names are self-explanatory. You just need to understand the full form of LRU, LFU, TTL to understand what that key is talking about. Now, volatile LRU evicts the least recently used keys that have the expire field set to true. Volatile LFU evict the least frequently used keys that have the expire field set to true. Volatile random, similar to all keys random, is going to evict keys at random only if they have the expire field set to true. Volatile TTL is going to evict keys with the expire field set to true that have the shortest remaining time to live value. So friends, the key difference between all keys and volatile is all keys, as the name indicates, is going to look at all the keys, whereas the volatile policies are going to look at the keys which have the expired field set to true. Then LRU and LFU are same. Let's now look at next question in the series. You are developing an Azure App Service hosted ASP.NET Core Web App to deliver video on demand streaming media. You enable an Azure Content Delivery Network standard for the web endpoint. Customer videos are downloaded from the web app by using the following example URL. There is a URL in front of you. All media content must expire from the cache after 1 hour. Customer videos with varying quality must be delivered to the closest regional point of presence node. You need to configure Azure CDN caching rules. Which option should you use? The first part of the question is talking about cache behavior. And your options are bypass cache, override, set if missing. Friends, cache behavior should be override as it forces a specific cache duration regardless of origin headers. This is best choice here since we want a strict 1 hour cache expiration. Now the next part of the question is talking about cache expiration duration, and your options are 1 second, 1 minute, 1 hour or 1 day. Cache expiration duration will be 1 hour as it is clearly mentioned in the question as well. The content must expire from the cache after 1 hour. This is the statement I'm talking about. Now the next part of the question is talking about query string caching behavior. Your options are ignore query strings, bypass caching for query strings, cache every unique URL. Here you will choose cache every unique URL. It ensures each variation of quality equals to X is cached separately. You deploy an ASP.NET web app to Azure App Service. You must monitor the web app by using application insights. You need to configure application insights to meet the requirements. Which feature should you use? Now friends, the first requirement is automatically warn you of potential performance problems and failure anomalies in the web app. Your options are smart detection, snapshot debugger, profiler, multi-step test. And folks, you should make use of smart detection here. Smart detection automatically analyzes telemetry and sends proactive alerts about performance degradations, failure anomalies, and potential issues. Now the next part of the question is talking about automatically collect the state of the source code and variables when an exception is thrown in the web app. Again, you have the same 4 options. And friends, in this case, you will have to use a snapshot debugger. Snapshot debugger captures a snapshot of the process at the moment an exception is thrown, including local variables and the call stack. Now friends, the third part of the question is talking about capture performance traces of the web app without negatively affecting users of the web app. Profiler would be the right feature to use in this case. Application Insights Profiler collects detailed performance traces with very low overhead, so it doesn't impact end user experience. Let's look at question number 64 of the series. You develop new functionality in a web application for a company that provides access to seismic data from around the world. The seismic data is stored in Redis streams within an Azure cache for Redis instance. The new functionality includes a real-time display of seismic events as they occur. You need to implement the Azure cache for Redis command to receive seismic data. How should you complete the command? Now friends, there are basically 3 blocks that you need to fill in the whole command. And the correct command is now on your screen. Xread reads new entries and can block and wait for new messages, making it perfect for real-time consumption. To continuously wait for new data, use block, and 0 means wait indefinitely until new data arrives. And stream ID would be $, which means start from new messages only, not old history. Next question. You develop and deploy an Azure App Service web app that connects to Azure Cache for Redis as a content cache. All resources have been deployed to the East US 2 region. The security team requires the following audit information from the Azure cache for Redis. The number of Redis client connections from an associated IP address, Redis operations completed on the content cache, the location in which the Azure cache for Redis instance was accessed. The audit information must be captured and analyzed by a security team application deployed to the central US region. You need to log information on all client connections to the cache. Which configuration values should you use? The first part of the question is talking about to store the log information. Your options are Log Analytics Workspace, Blob Storage Account, Data Lake Storage Zen 2 Storage Account, Event Hub. Folks, you should use Log Analytics Workspace to store logs. It is best for collecting telemetry and running queries with Azure Monitor and can be consumed by downstream apps. Now, Blob Storage Account is best used for archival. Data Lake Storage Zen 2 is typically used for big data analytics pipelines, and Event Hub is best for streaming to SIEM or external app. Now the next part of the question is talking about enable client connection logging, and your options are diagnostic setting, managed identity, app registration, environment variable. Correct way to enable logging and send logs to Log Analytics is to use diagnostic setting. Managed identity or app registration is used for authentication, and environment variable is not relevant to Redis logs at all. Question number 66 of the series. You are developing an ASP.NET Core Web API web service. The web service uses Azure Application Insights for all telemetry and dependency tracking. The web service reads and writes data to a database other than Microsoft SQL Server. You need to ensure that dependency tracking works for calls to the third-party database. Which two dependency telemetry properties should you use? Your options are telemetry context cloud role instance, telemetry ID, telemetry name, telemetry context operation ID, telemetry context session ID. And friends, the correct answers are now on your screen. Telemetry ID is a unique identifier for the telemetry item itself. This is used to correlate a dependency call with its parent request. Now, telemetry context operation ID links all telemetry, which includes request, dependency, trace, exception that belong to the same end-to-end operation. Now friends, there is a link on your screen. Go through the link to understand these dependency telemetry properties in more detail. Question number 67. You develop and deploy an Azure App Service web app. The app is deployed to multiple regions and uses Azure Traffic Manager. Application Insights is enabled for the app. You need to analyze app uptime for each month. Which two solutions will achieve the goal? Your options are Azure Monitor Logs, Application Insights Alerts, Azure Monitor Metrics, Application Insights Availability Tests. Now friends, Application Insights send availability telemetry data to log analytics. With Kutso queries, you can aggregate results over monthly windows to calculate uptime percentage, making it perfect for long-term analysis. Now, Azure Monitor Metrics can capture availability percentage and can be aggregated over time ranges. You can view monthly uptime trends in Metrics Explorer or export them. Now, friends, Application Insights Alert notify you in real time when conditions are met, but they do not provide monthly uptime analysis. Application Insights Availability Tests generate the availability telemetry in the first place, but that does not directly relate to analyzing monthly uptime, which is why I have ruled it out. Folks, if you're liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 68 of the series. You are implementing an Azure solution that uses Azure Cosmos DB and the latest Azure Cosmos DB SDK. You add a change feed processor to a new container instance. You attempt to read a batch of 100 documents. The process fails when reading one of the documents. The solution must monitor the progress of the change feed processor instance on the new container as the change feed is read. You must prevent the change feed processor from retrying the entire batch when one document cannot be read. You need to implement the change feed processor to read the documents. Which features should you use? Now friends, the features that are given in the options are change feed estimator, dead letter queue, deployment unit, and lease container. Now the first requirement is monitor the progress of the change feed processor. Now friends, the change feed estimator provides insight into how many items remain to be processed and helps monitor the processor's progress. Now the next part of the question is talking about prevent the change feed processor from retrying the entire batch when one document cannot be read. The dead letter queue allows problematic documents to be moved to a separate container when they fail processing, preventing the entire batch from being retried. Now folks, the remaining options, deployment unit refers to how you package and deploy the change feed processor application. And the lease container is required by the change feed processor to track state and distribute work among multiple processor instances. Next question. You develop a solution that uses Azure virtual machines. The virtual machines contain code that must access resources in an Azure resource group. You grant the VM access to the resource group in Resource Manager. You need to obtain an access token that uses the VM's system assigned managed identity. Which two actions should you perform? Your options are: from the code on the VM, call Azure Resource Manager using an access token. Use PowerShell on a remote machine to make a request to the local managed identity for Azure Resources endpoint. Use PowerShell on the VM to make a request to the local managed identity for Azure Resources endpoint. From the code on the VM, call Azure Resource Manager using a SAS token. From the code on the VM, generate a user delegation SAS token. Now friends, the correct answers are now on your screen. There is a link on your screen, folks, which you can refer to understand the whole process in more detail. Option B is incorrect, as the managed identity endpoint is only accessible inside the VM. And option D and option E talk about SAS tokens, which are for storage, not Azure Resource Manager. So friends, you could either understand how I came to the solution by understanding the logic behind the question, or you could try the elimination approach. As you can see, the last two options can clearly be ruled out because you use SAS tokens with a storage account. And then option B can also be ruled out because the managed identity endpoint is only accessible inside the VM. This leaves us with only two options, option A and option C, which are the correct answers. Let's look at question number 70. You are building a loyalty program for a major snack producer. When customers buy a snack at any of 100 participating retailers, the event is recorded in Azure Event Hub. Each retailer is given a unique identifier that is used as the primary identifier for the loyalty program. The retailers must be able to be added or removed at any time. Retailers must only be able to record sales for themselves. You need to ensure that retailers can record sales. What should you do? Your options are: use publisher policies for retailers, create a partition for each retailer, define a namespace for each retailer. Now folks, Event Hubs supports publisher policy. Each retailer can send events to Event Hub using a URI with its publisher ID. This enforces that the publisher, which is retailer in this case, can only publish under its ID. You don't need to create separate hubs partitions for each retailer, and retailers can be added or removed dynamically by managing SAS tokens or keys. Friends, as always, there is a link on your screen. Go through the link to understand more about publisher policies in Event Hubs. Question number 71. You are developing an Azure service application that processes queue data when it receives a message from a mobile application. Messages may not be sent to the service consistently. You have the following requirements. Queue size must not grow larger than 80 gigabytes. Use first in, first out ordering of messages. Minimize Azure costs. You need to implement the messaging solution. Friends, the solution you choose is: use the .NET API to add a message to the Azure Service Bus queue from the mobile application. Create an Azure function app that uses an Azure Service Bus queue trigger. Does this meet the goal? You need to tell whether this is right or wrong. And friends, this is a correct solution. Let's understand some of the scenarios where Microsoft recommends the use of Service Bus queues. So folks, as per Microsoft documentation, as a solution architect or developer, you should consider using service bus queues when your solution needs to receive messages without having to poll the queue. With service bus, you can achieve it by using a long polling receive operation using the TCP-based protocols that service bus supports. Your solution requires the queue to provide a guaranteed first in, first out ordered delivery. This is one of the requirements that we had in our question. Your solution needs to support automatic duplicate detection. You want your application to process messages as parallel long-running streams. In this model, each node in the consuming application competes for streams as opposed to messages. When a stream is given to a consuming node, the node can examine the state of the application stream state using transactions. Your solution requires transactional behavior and atomicity when sending or receiving multiple messages from a queue. Your application handles messages that can exceed 64 KB but won't likely approach the 256 KB or 1 MB limit depending on the chosen service tier. So friends, even though this was not one of our requirement in the question, but you should always take into consideration the message size when choosing service bus queues. Now, you deal with a requirement to provide a role-based access model to the queues. Your queue size won't grow larger than 80 GB. Again, this is one of our requirements. If the queue size is going beyond 80 GB, then you are not going to use service bus. You want to use AMQP 1.0 standards based messaging protocol. You envision an eventual migration from queue-based point-to-point communication to a publish-subscribe messaging pattern, which is pub-sub pattern. This pattern enables integration of additional receivers, which is subscribers. Each receiver receives independent copies of either some or all the messages sent to the queue. Your messaging solution needs to support the at most once and at least once delivery guarantees without the need for you to build the additional infrastructure components. Your solution needs to publish and consume batches of messages. So friends, if you want to understand why I didn't go ahead and choose storage queues here, then just keep scrolling on this page and look for the comparison between the storage queues and service bus queues, and you will understand why storage queues cannot be used here. So folks, go through this comparison table to understand in which use cases you should use storage queues and in which use cases you should use service bus queues. You have 100 Azure virtual machines with the system assigned managed identity enabled. You need to identify the value of the object ID attribute for each of the identities. Which command should you use? Your options are get Azure AD user, get AZ resource, get Azure AD user owned object, AZ AD signed in user list owned objects. Folks, you can use get AZ resource commandlet, which can list all resources including VMs. When the VM has a managed identity enabled, the VM resource contains an identity property with the object ID of that system assigned identity. And the right command is now on your screen. Let's look at question number 73 of the series. You develop applications that integrate with Microsoft Entra tenant. You plan to implement a permission classification in the tenant. You need to select permissions to include in your classification. Which permissions should you select? Your options are app-only access permissions that require admin consent, delegated permissions that require only user consent, app-only access permissions that require only user consent, delegated permissions that require admin consent. To implement a permission classification in a Microsoft Entra tenant, you should select delegated permissions that require only user consent. This is because permission classifications in Microsoft Entra ID currently support classifying delegated permissions that do not require admin consent. Next question. You have an Azure virtual machine named VM1 running Windows Server 2022 and an Azure Key Vault instance named KV1. You are developing a .NET application named App1 that you plan to deploy to VM1. You have the following requirements. App1 will require access to KV1. The identity used by App1 to access KV1 must be automatically deprovisioned when VM1 is deleted. You need to identify the procedure that will meet the requirements. Which 3 actions should you include in the procedure? Your options are create a user assigned managed identity for the VM, modify access policy on KV1, retrieve an access token from Azure instance metadata service endpoint, create a system assigned managed identity for the VM, retrieve an access token from the Microsoft Identity Platform endpoint. Now folks, you should start with creating a system assigned managed identity for the VM. This ties the identity lifecycle to the VM. When VM1 is deleted, the identity is automatically removed. Next section would be to modify access policy on KV1. This includes granting the VM's managed identity the required permissions. This allows the identity to be used for key vault access. And the last step would be to retrieve an access token from Azure Instance Metadata Service endpoint. Code inside the VM calls the local endpoint and gets an access token from the key vault. Next question. You are developing a Java application to be deployed in Azure. The application stores sensitive data in Azure Cosmos DB. You need to configure always encrypted to encrypt the sensitive data inside the application. What should you do first? Your options are create a new container to include an encryption policy with the JSON properties to be encrypted. Create a customer managed key and store the key in a new Azure Key Vault instance. Create a data encryption key by using the Azure Cosmos DB SDK and store the key in Azure Cosmos DB. Create an Entra ID managed identity and assign the identity to a new Azure Key Vault instance. Friends, you should create a CMK and store it in the Key Vault. Client-side encryption in Cosmos DB uses a two-tier key system. Customer managed key, which is called as CMK, and data encryption key, which is called as DEK. CMK is the master key you control and store securely, typically in Azure Key Vault. Now, DEK is used to encrypt or decrypt the actual data fields, which is stored in Cosmos DB, but always encrypted with the CMK. So friends, I hope you now understand what is the concept of CMK and DEK and how they are used in Azure Cosmos DB. Folks, that's all for this part of the series. I'll see you soon in further parts of our Microsoft Certified Azure Developer Associate Ultimate course. If you have not watched the previous parts of the series yet, then link to the playlist is available in the description section of the video. Make sure to explore all the videos to gain the maximum benefit from our content.